Dear students, welcome to the problem solving session on mean deviation, about the mean and about the median and mode. At first, you should have to learn how to find arithmetic mean, median and mode. If you don't know how to find this, go to the playlist, watch that video and come back here. Let us write the formula first. For ungrouped data, mean deviation about the mean is summation modulus of x minus x bar divided by n, or we can say summation modulus of x minus mean divided by n. To find the mean deviation about the mean, first of all we have to find the arithmetic mean. Now for the case of grouped data, whether it is discrete or continuous, the formula is going to be summation, the frequencies f into modulus of x minus mean divided by capital N. We know that capital N is summation of all the frequencies. We can see the characteristics of mean deviation about the mean. Next, if it is median, instead of mean, I am going to replace median. So that means for this problem, first of all, I should have to find the median. So this is the formula for grouped data. For ungrouped data, we have a formula summation modulus of x minus median divided by number of observations, and you can see the characteristics of mean deviation about the median. In the similar way, for ungrouped data, summation modulus of x minus mode divided by number of observation. For grouped data, either discrete or continuous, summation f into modulus of x minus mode divided by capital N. You can see the characteristics of mean deviation about the mode. So now I am not going to do any new problems. I am going to do the mean deviation about the mean, about the median, about the mode part alone. So I am going to take the problem which we already solved for mean, median, mode. While we compare, we see mean deviation about the mode is highest and mean deviation about the median is lowest, and mean deviation about the mean is the middle value. Now for the discrete case, we solved arithmetic mean. We took the same problem. Now we are going to find the mean deviation about the mean. So I am just skipping all these things. We first found arithmetic mean, that is 61.88. Now in the same table, we have to find f into modulus of x minus x bar. One small problem in our calculator, there is no modulus operation in this calculator. Maybe in the higher versions they have. So what we have to do, when we write the prompt, simply write x minus, here x bar is 61.88, then f. So when you press calc, it will ask x value and f value. When you enter, there may be a chance this may be negative, but we are doing mean deviation about the mean. None of the values should be negative. Even your calculator is showing negative, you have to write positive because this option is not available in the calculator. Don't worry whether it is showing negative or positive. Simply before filling the table, put plus everywhere. And then now fill the values like this. So all your values should be positive. Even suppose you are writing negative, no issues. After filling the table, make everything positive. This is the only thing you have to do. Now, mean deviation about the mean is summation f into x minus mean divided by capital N. My capital N is 60 and this summation is 76.872. You can simplify with your calculator and get the answer. Therefore, the mean deviation about the mean is 1.281. For the case of continuous, the only one thing is we have to find the midpoint extra. To find x, remaining things are same. First we have to find the arithmetic mean, that is going to be 28. Next we have to add one more column here to find f into modulus of x minus x bar. I am telling you again, in calculator find like x minus 28 into f and you just fill the table because there may be some chances if my x value is less than 28. For example, for 5, 15, 25 you get negative. But while you filling the table at the end, you have to make this as positive. Write everything is plus, otherwise you lose your marks. And then write the mean deviation about the mean, adding the sum and divide by capital N. In the same way, you're going to do for median. You take the problem, first find the median. All these things we have did earlier. From the median, we have to make the table, and here f into x minus median. That is the only difference. Now same technique which I tell, use calculator, fill whatever you are getting, and remember at the end of the problem, make everything positive. So you will never do error. Then find the mean deviation about the median. In the similar way, find the mean deviation about the mode. First find the mode, and then for the table x minus 27.14 into f. So here guarantee that 5, 15 you get negative. But at the end, what you do? You take the problem, make everything positive, so you never get error. Fill the data and then find the sum, and you can find the mean deviation about the mode is 10.93. Hope you understand, students. Sometimes instead of normal coefficient of skewness, people may ask you to find Carl-Pearson coefficient of skewness. So let us see what is meant by Carl-Pearson coefficient of skewness. Carl-Pearson coefficient of skewness gives the relationship between mean, median and mode, and it will find the skewness obviously for asymmetry of a distribution. So the formula is mean minus mode divided by standard deviation. This is the easy formula we use. So whenever the problem comes in your exams, if they give a data whether it is discrete or continuous, if they are telling you to find Carl-Pearson coefficient of skewness, then no other go. First we have to find mean, then we have to find mode, and then finally we have to find standard deviation and substitute in this formula. Or there is another option. Suppose you think that finding median is easy for you, find mean, median and then standard deviation. Then the alternative formula is 3 into mean minus median divided by standard deviation. So either you can use the first formula or the second. So now interpretation. If the distribution is symmetrical, then Carl-Pearson coefficient of skewness will become 0. So for skewness, I'm taking SQ. Since it is coming from Carl-Pearson, I'm just giving the notation KP. If it is positively skewed, then it is greater than 0. If it is negatively skewed, it is less than 0. So the ranges lies between minus 3 to plus 3. Next, similarly, they can ask Bowley's coefficient of skewness. To find Bowley's coefficient of skewness, we need the quartiles, that is Q1, Q2, Q3. Let us see the formula. This is the formula for Bowley's coefficient of skewness. When you simplify this, I can write this as Q3 plus Q1 minus 2 times Q2 divided by Q3 minus Q1. So we have to find all the three quartiles Q1, Q2, Q3. Then we can substitute in the second formula rather than the first formula. Then you can get Bowley's coefficient of skewness. Same thing. When it is 0, it is symmetrical distribution. When it is greater than 0, it is positively skewed. When it is less than 0, it is negatively skewed. And this range lies between minus 1 to 1. Hope you understand, students.
Thanks for watching. Hope you found this video helpful. Subscribe to our channel and share it to your friends. See you in the next video. Bye bye.